Okay, so today we're looking at our first derivative test, which is kind of similar to our candidates test. It allows us just to find information about our function as well as our graph of our function. So chapter 3 is all about what we call analytical applications, just meaning about our function, about the graph of the function, things like that. So again, we've learned how to take all of these derivatives. Now we're applying them or using them to find information. In our next unit, after we come back from winter break, those are what we call contextual applications, which are basically word problems. So it's like, how can we apply derivatives to help us find real world information that we need. So, we're talking about increasing and decreasing. What do I mean by increasing and decreasing? What does that mean?
The derivative is positive.
What is positive? Like, what does that mean?
The rate of change.
Yeah, no, but you just said when the derivative is positive. I have two different things in there. I have increasing and decreasing. So, like, the derivative is positive means it's increasing and decreasing?
Just increasing.
Why?
Because when the derivative is positive, the rate of change is positive.
Okay. Or the slope of the
Tangent line.
Yeah. Alright, okay, that if I draw a tangent line there, yeah? Okay. So what do we mean by increasing in general though? Like what's happening on my graph?
Up until the
Y is going up.
The y is going up as the
X goes up to the right.
as the x gets larger. Yes. So we're talking about moving to the right. So we're talking about our x is getting larger. So if I'm increasing, then my y's are also getting larger. Versus if I'm decreasing, our x's are still getting larger, but now our y's are getting smaller. Okay. So when we have linear graphs, it's real easy because it's just our rate of change is constant. We just call it a slope. So our slope is positive or negative. When we have a curved function, it's not quite as easy to figure out when we are increasing or decreasing without just graphing it. But we can also look at these like slopes of the tangent lines. So notice that as my slope of the tangent line is positive, right, that means that my function will be going up and to the right. As my slopes of the tangent lines are negative, it's going to be going down. And we know that our slopes of the tangent line are also our derivatives. Yeah, so we will be increasing when f prime of x is positive and decreasing when f prime of x is negative. Which we've talked about before in some of our, we've looked at some graphs and things like that. However, we haven't actually like fully found like where we're increasing or decreasing given a function. Which is what we're looking at today. So it says determine where the function is decreasing. So what do we say we want to look at if we want to know where it's decreasing?
Slope of the tangent line.
Okay, which is also our derivative. Okay, so then what might it be helpful to find?
The derivative.
The derivative. So what is my derivative of that function?
3x squared minus 12x. 20.
Yep. We're okay with that. It's polynomial, we're just using our power rule. Now, if we need to know where that thing is negative, yes, we could just like plug and chug all the numbers, right? Which would not be super fun. No, yeah. So, we also know, okay, that the only places that we can change from either increasing to decreasing or decreasing to increasing, right, or positive to negative, negative to positive, are going to be where my derivative is 0, okay? So we can find where it equals 0 and then kind of use that information to only have to plug in a couple of values instead of all the values. Are we with me there? Alright, so to find where it equals 0, I'm going to set it equal to 0. What are these also called when I set it equal to 0?
Critical points.
Our critical points. So we're going to find our critical points, which is where it equals 0. The other spot that we have to worry about for our critical points is where we are what?
Undefined.
Undefined. This is a polynomial. Is it going to be undefined anywhere? No, so we're good. Now, how would I solve that?
Factor 3x out.
Okay, and we're left with?
3x times x minus 4.
So we get 2 critical points. One at 0 and one at 4. Yes, no, maybe. So we know that those are the only spots where it can change from positive to negative or negative to positive. So now instead, I only have to pick 3 values to plug in, right? Basically in each one of my intervals. Because then I know that for that whole interval, it has to be either positive or negative, okay? Because the only spot it can change is at 0 and 4. Are we all with me there? Now, in this case, we don't necessarily care where it's positive, but we're still going to find the positive spots as well. Now, the big difference here between the candidates test, okay, is that we said we are decreasing when what is negative?
F prime.
F prime, right? So I need to know if F prime is positive or negative. So we're going to be plugging values in for F prime. Versus remember with our candidates test, I did plug back into my original function. Are we all with me there? Which is why today's stuff is called the first derivative test, because we were plugging back into the first derivative. Now, I use a number line here to help me like keep track of all of my stuff. You are welcome to use like a table instead if that's more your jam, or like some other way of organizing it is fine. You do want some sort of way to organize it, not just like random things written everywhere, okay? I like the interval, like the number line just because it's very visual and it's easy for me to see, but if you like a table more, that's also a really common way. So the first thing we want to pick is a value in our first interval, so something that is to the left of 0. Negative 1, that's fine. You can pick whatever, as long as it's in that interval. I would also not pick something that's like 2.7562, right? Like pick something that's going to be easy to plug in. And then remember that we are plugging back into my derivative, yes? Now, when I'm looking at my derivative, okay, is negative 1/2 negative?
Yeah.
Yeah, is negative 1 million negative?
Yeah.
Do I care how negative my negative is? Do we care how positive the positive is? No, we just care about the sign, right? If it's positive or negative. So we are not going to spend the time figuring out what the actual value is. We are only going to think through, is this thing positive or is this thing negative? Are we all with me there? Alright. So if we plug into our derivative, I'm going to go ahead and plug into factor form. Because again, if I'm looking for positives and negatives, multiplying two things that are positive and negative is much easier to figure out what's positive and negative versus trying to subtract them. Are we all with me there? Alright. So if I plug negative 1 into this first factor, so 3x, is that going to be positive or negative? Negative. Times, if I plug negative 1 into the second factor, is that going to be positive or negative? Also negative. So a negative times a negative is a positive. So that means that before 0, what is our graph doing? The graph is not positive, right? I don't have enough information to know if my graph is positive or negative. However, I do have enough information to know that my graph is increasing, because this is my derivative. Alright, then what's the value between 0 and 4?
1.
Sure. So this time, if I plug 1 into my first factor, what do we get? If I plug it into my second factor, what do we get? Negative. So a positive times a negative is a negative. And then lastly, what's the value after 4 that we can pick?
5.
Sure. And what are we going to get this time? So my first factor is, my second factor is also positive, so overall we are positive. Okay. So we specifically only care where the function is decreasing this time. Yes? So where are we decreasing?
Between 0 and 4.
Okay, so you have two options. You can either write this in interval notation, so 0 to 4, or you can write 0 is less than x is less than 4. Either one's fine. I tend to write the interval notation, but whichever one makes you happy. Do notice that because I'm talking about increasing or decreasing, right? So like we're comparing two y values. I'm saying this y value is smaller than my previous y value. That means that I have to have two y values to look at. So when we're talking about increasing and decreasing, we do not include the endpoints because I am not increasing or decreasing like at one point. Does that kind of make sense?
Yeah.
Which is why, like, I'm not going to count wrong, and the AQ test does not count off if you put hard brackets on these, but just standard notation is to put the parentheses and, like, no equal to bar on there. What questions do we have on that? Okay. Yeah.
Would there be like a case where there'd be like two intervals?
Yeah. Because, like, same thing here, right? If I had asked you for where it's increasing, yes, it would have been negative infinity to 0 and 4 to infinity. So it just depends on what your graph looks like. Because, like, on the one I drew here, right, we are increasing whatever value that is up until there, but then I'm also increasing after that. Does that make sense? And you would just put, like, a comma or an and or a union symbol. Any of those are fine if you have more than one. Good question. Other questions? Okay, it's everyone's favorite. We got a trig function.
Yay.
Yay! We need more practice with our trig functions. So they're going to keep going up. So this says determine where the function is increasing this time. So again, what do we need in order to figure out increasing and decreasing? The derivative. Okay, what's our derivative of cosine?
Negative sign.
Cool. And then, what do I have to apply though for this derivative? The chain rule, because we have stuff inside our cosine. Yes? So what is the derivative of x over 2? 1. Now, most of us on our last test were able to take our derivative just fine. It was the part where I then asked you to solve a trig equation without our calculator. Some of us struggled a bit. We should know how to solve basic trig equations without a graphing calculator. And that's just an expectation. Okay. So in this case, I have negative 1/2 times sine of x over 2 equals 0. So how do I solve for that x?
Couldn't you multiply both sides, or at least divide both sides by negative 1/2?
Yeah, or multiply by negative 2. Either way is fine. Cool. So I have 0 equals sine of x over 2. So remember our first goal in solving a trig equation is to get the trig function by itself. Then we use either our knowledge of the unit circle or our knowledge of what the graph of sine looks like. Either one is fine. What does our graph of sine look like?
0, 1, 0, -1, 0.
Yes. So it starts at a 0, yes? Okay. Versus cosine starts at a 1. And normally, this is 0. Where does it end? 2 pi, and so halfway in between is going to be another 0, but also pi. We're okay with that. Where's that graph? Equals 0.
0, 5, 2, 5.
Yeah. And I do have endpoints here, so I'm going to include all those. Now, me finding those value undoes my sign, okay? But I'm still left with whatever's on the inside. So right now I have x over 2 equals 0, pi, and 2 pi. Yes, no movie. We're okay with that. So then what's my last step to solve for x in this case? Multiply by 2. So 0 times 2 gives us
0,
pi times 2 gives us 2 pi. And then 2 pi times 2 gives us
4 pi.
4 pi. What's my interval?
0 to 2 pi.
Yep. So now we don't care about that 4 pi anymore. Well, if my interval is 0 to 2 pi and my critical points are 0 to 2 pi, how many things am I going to have to plug in? Just one, right? Because it's going to be doing the same thing that entire interval. So I need to know, is it increasing or is it decreasing? But it's going to have to do the same thing for that entire interval. Which, remember, it's because when I have something that's dividing by 2, right? Remember, this is the b value. If my b value is a fraction, it's going to stretch out the period. So now this is going to be decreasing from 0 to 2 pi. Question? Okay, so what is a value in between 0 and 2 pi that we want to plug in? Pi, sure. We do want to pick something that's a degree, or that's a angle this time, because we're plugging back into a sign. So we don't want to pick like 1, because sine of 1/2 would not be a very pretty answer. But if I pick pi, remember I am plugging back into my derivative this time. Okay. So let's think about what is sine of pi over 2. Is it a positive 1?
Yeah.
Yep. And so then I would have a negative 1/2 times a positive 1. So overall, we will be negative. So what is my graph doing from 0 to 2 pi? Decreasing. So that means that we'll determine where that function is increasing. Where is it increasing? On that interval.
It's
Nowhere, yeah. Or you could put it's not. Or you could also put the empty set. So it's the like 0 with the slash through it. What questions do we have there? Yeah.
So it's always decreasing?
On that interval, yes. Because I'm only looking from 0 to 2 pi. So what's happening here is my graph of cosine normally starts at a maximum, right? And then it decreases. And usually it only decreases until I get to pi. But this time, because of the divided by 2, it's going to decrease all the way until I get to 2 pi.
So if it was just cosine x, it would be decreasing and increasing?
Correct. Yeah, you would have different intervals on this one. Yeah, or if it had been like 2x, it would actually make my period shorter, so you would have more spots that it was increasing and decreasing instead of less. Other questions? Alright, so now we're going to take it a step further. So this is called our first derivative test. So we said that we know when we are increasing or decreasing based upon where our derivative is positive or negative. Yes? Okay. We also said that I can only switch between increasing or decreasing or positive or negative for our derivative when we have what type of values? Critical points, yeah? What else is happening at our critical points? Turns, yeah. So we called those our turning points, which we also called our what for our original function? Yeah, what kind? Relative. So those have to be relative extrema. So what our first derivative test basically allows us to do is take this idea of increasing or decreasing a step further, and that we're able to find where we have relative extrema. So remember for our candidates test, that only found us absolute extrema. Now sometimes our absolute extrema can be at our relative extrema, but not always. So our first derivative test now allows us to find our relative mins and maxes instead. So we're going to start with the most generic case, which is where we're going to let f of x be differentiable. Yes? We like differentiable. That means that we have nice pretty trig functions, nice pretty polynomials. It makes our lives a whole lot easier. We will talk about what we do if it's not differentiable in just a moment. So if it is differentiable and f prime of c equals 0, okay, What does that mean about C? What's happening on my graph? It's a turning point, right? But now what we have to decide is we want to know which type of turning point it is. Is it a relative max or is it a relative min? And so what we do, it's kind of the same thing we've been doing. We're going to look at that number line because we know if f of x changes from positive to negative around x equals c, then x equals c must be a, so it means that we're going from increasing to decreasing, yes? So it's a turning point, but it's specifically going to have to be like the top turning point, okay, or a relative max. If f of x changes from negative to positive, basically we have the opposite. It would be a relative minimum. Alright, I'm okay with that. Now, the reason why I said that f of x has to be differentiable is because I put must there, okay? Because the second that f of x is not differentiable, it causes us to have issues. Because we have two different cases on that one. So if f prime of c is undefined, okay, then x equals c is either a relative extrema or a discontinuity for f of x. And so basically the two different cases that we can have for that is if I have like an absolute value. Yes? Are you with me? So as at my vertex is f prime of c defined.
Yes.
F prime of c is defined at our vertex? No, it is not. Okay? However, it is going to change from decreasing to increasing, yeah? So then what I have to do is look back at my original function and go, okay, f prime of c is not defined, but f of c is defined, which means that I have a relative min there. However, versus if I had like a rational graph, yes, that goes from increasing to decreasing, I'm looking at x equals c, and now I look at my original graph, or my original function, I go, f of c is not defined for my original, so that's why it's a discontinuity. So I can still change, right, because I'm hopping, so I can still go from increasing to decreasing, but because I don't have a value there, it's not considered a relative extrema. It just changed from increasing to decreasing. Yes, no, maybe? Okay. So let's look at some examples with this. The first being from a graph. So this says, consider the graph of f prime of x, where f prime is the derivative of f. Find the intervals where f is increasing and decreasing, and state the location of any relative extrema. Yes, no, maybe. What is my graph of?
F prime.
F prime. What do you think might be a common mistake when we've given a graph? To treat this as just f, right? And they'd be like, it's increasing from -4 to -2, whatever that is, 1/2 afterwards, right? And be like, my relative extrema are -4, -2, and 1/2, or whatever, right? But as we add in more stuff, okay, we are now going to be given graphs that could be f of x, they could be f prime of x, they could be f double prime of x. So you have to make sure that you are checking the graph label if they give you a graph. They should also tell you in the instructions, like if it's a multiple choice question or if a response question, it's going to say given the graph of f prime, f double prime, whatever it is. But it's also usually labeled on the graph itself. Okay. So if this is f prime instead of f, how do I know where we are increasing and decreasing? Correct, and that means for my graph where we are above or below the x-axis, yes? So we will be increasing on our original function when f prime is above our x-axis or positive. So where is that graph positive? And? Okay. Yes, no, maybe? Or how maybe we'll see that from the graph. Okay. What about decreasing? Here. Okay. Now, for where our relative extrema are, what are we looking for? Where are we what?
Have an undefined or zero.
Have an undefined or zero slope, okay. Do I have anything that's undefined on that graph? No, so I'm just looking for where it's zero, yes? So what are the 3 spots that it's zero? Okay, do I have relative extrema at all of those? No, I see no's. Why?
Because negative 4 is positive to positive.
Ah, okay, so I'm not changing. So what type of graph would look like that? Where it has a horizontal tangent, but then continues going the same direction. What's one of our functions that does that?
One of them.
Which one looks like the S shape?
Is it a log?
Oh, it's not a log. It's actually an x cube, right? A cubic graph, or your tangent graph does that too, right? Where it like levels out in the middle, but then it continues going the same direction that it was. So you're gonna have a horizontal tangent line there, okay? But it's not gonna be a relative min or max because it's gonna continue going the same way it was. Now, so do we change signs at -1 and 1 though?
Yes.
Yeah, but we do need to decide what type they are. So -1 is going from positive to negative. So on my original function, what does that mean it's doing? It's a maximum because I'm going from increasing to decreasing. So this is a relative max. Versus on the other one, we're going from negative, so decreasing to increasing. So we would have a relative minimum. And if it helps you, like, draw out the picture, like decreasing to increasing, increasing to decreasing, or do the hand motions, that's cool too. Alright, whatever helps you visualize what the original graph is doing. What questions do we have there? Ready to look at a more mathy question?